Good morning.
Morning.
A couple people. So I'm Brian McDonald, Productivity Quality. We've got our webinar on PC-DMIS. It's going to be fairly basic level for today. Cover a few different things: probe calibration, working with CAD, alignments, and working plans. With me is John Vernon.
Hey everybody, John Vernon. I work at AIS, applications guy. So I've been doing PC-DMIS for a while. Again, like Brian said, this is pretty basic. This is the first webinar that we're doing as a company. We kind of went around and asked people what our biggest customer support calls were, and this is what it was. So we're starting there. We plan on doing more of these, which will get more in depth as we go along. So, any questions, if you guys could just go to the chat and we'll answer all the questions as they come in. And that way we don't get a bunch of people talking over everybody. So that would be appreciated. So any questions before we get started? I guess we're gonna go ahead and roll with it. We are recording this. I think the plan's to send a recording out to everyone that signed up when it's all done. So this isn't a once and done. You'll get an email with a link to it, so you'll be able to keep it forever. All right, I'm gonna get started. One of the biggest problems that we have, or biggest customer support things that we get, is probe calibration. A lot of people don't understand some of the questions they're asked, or things get hidden when they are trying to build a probe. Oh, we're not presenting. Thank you, Hannah. Okay, now we're rolling. So one of the things that we've had just recently is one that I had is actually, go back here. If we do a new probe, we give it a name, and then everything comes up. And what had happened was this had become not highlighted for the person when they went in, and there's nothing in the drop down. So if that ever happens, it's this button. Pretty easy fix. It took a while to get to it, but that's what it is. Another thing we get is this favorites button. If you check that favorites button, the only thing that shows up is what you have designated as a favorite. And to set favorites is highlight it, right click, and you can turn it on and off right there. It's pretty handy if you have probe systems, different probe systems on different machines. You can just set the ones that you have, PH10 or the hexagon probe system, and it will keep everything just as we go. So the probe calibration, from this point, we can go ahead and add angles, and we'll just add them from CAD so we can get some in there pretty quick. When you go to measure, some stuff down here in the bottom right, this one's set to all. So if tips are not selected, what are we going to do? If you have abort execution checked, it just stops because there were no probes selected. So you can set used in routine. That's going to do everything in the program, or you can do all, and that's everything in the list. And from there, we're ready to, we can get started. I guess let's back up a minute. The setup tab, this was one that people have asked, hey, how do I see my previous calibrations? and it's that checkbox right there, the append calibration results. This will keep a running record of every time this test probe has been calibrated. That's handy for going back and checking history on your probe cals. If it always calibrated at 1/10, and then all of a sudden it's calibrating at 2/10, what happened? What went wrong? You know, do I have one that's always 2/10? I'm probably not going to get it any better than that. So just something, it does make the file a little bit bigger, but you can always go back and check it that way. And if we go to calibrate, we'll go ahead and check all. This was another one that confuses people, confused me a lot at the beginning. So has the tool moved? And this is talking about the cal sphere. Did you move the cal sphere, or did you even home the machine? If you home the machine, the locations change just a little bit every time the machine's homed. So if you physically removed the cal sphere and put it back in a different location, it's this button, the yes, manual hit to locate the tool. If you always screw the cal sphere back in the same spot, it's always in the same location, or all you did was home the machine, you can check that one. Machine's going to drive to the last known location of that cal sphere and start its calibration. If you have not moved it and you have not homed the machine, you can check no, and it's going to take off and run. We go back and we do say that it moved, we get an extra message that pops up. This message says, hey, one, I'm about to rotate to A0, B0. And the next question, the next statement is, in order for tips calibrated on the new position to relate to the tips calibrated on the old position, we had to have calibrated this probe at A0, B0 at the old location. This is if you are adding a probe or adding an angle. This goes back to PC-DMIS and the primary probe. So having a primary probe is beneficial because you can just go in and always grab that primary probe, find the location of the cal sphere at A0, B0, and then add angles to any probe you want by saying no to the question. So we say no here, and that keeps all your probes, the calibration, locked together. They're all linked. I can measure the same part using different probes, different locations, different wrist angles, and all the results are going to match and come in together. You know, able to use different probes, several probes in the same program. That's what that's for. If you say yes, it moved, then the probe you're using had not been calibrated at A0, B0 at the prior location, that new probe will not be linked to the rest of the probes in the rack or the rest of the probes that you're using in that program. So that's something just to keep in mind. If you start getting goofy results, that's something that may have happened. That button got checked to yes when it should have been checked to no. One other thing under probe cal that we get is collision detection. I think you must have that shut off because we're not getting that.
Oh, because I'm not on a machine.
Right. We're not on a machine, so we don't have a machine to load. Brian had a customer, as it was doing the calibration, they checked the box that says check for collisions on the calibration, and it ran into the probe rack. The machine doesn't know where the probe rack is. The machine, it's only looking for the legs of the machine and the granite. So if it's going to run into the probe cal, into the cal rack, that's not in that file that it's grabbing. So that was the problem with that. That does only look for the legs and the table as it spins around and does its calibration. And that covers about everything under what I had for probe calibration. One thing, if you break a stylus and you need to replace it, that goes back to the cal sphere. Has the tool been moved or not? If the tool hasn't been moved, replace your styli. Say no, happy days, everything's great. If you have moved the cow sphere, you need to go back to that primary probe, calibrate it at A0, B0, and then calibrate the replaced probe, and then everything's linked back together. So with that, and again, any questions, use the chat and we'll get them answered. Brian's going to take over and do a little bit with CAD right now. So I'll turn it over to him.
All right. Thank you. All right. So a couple things with working with CAD files that we've seen or run into recently. Start a new routine here, so I have no CAD file in. I had the question a couple times, how do I get CAD files in? Select the probe here. If I use my CAD import button, if it's not set to all files, you may not see the file format you're looking for. So if I'm looking for step files, you'll see my list becomes empty here. And I know that the format on this one is in IGES, so I've just got to select that, and I can select my CAD file or all files, and then I'll see it. That's one way you can import a CAD file. Pretty simple. The way I prefer to do it is just open up a folder with my CAD file, drag it, drop it on the screen. That message there, when you go to do it twice, if I import another CAD file, will say, do you want to merge with the data that exists or replace it? In this case, I had maybe the wrong one. I'll hit no to replace that file. So when the CAD files come in, this one with our demo block does have our alignment and our origin where we want it. Pretty common. It'll come in, the part maybe 90 degrees from where you want it, so the z-axis is the wrong way. 0 point's not where you want it. Especially with portable devices, portable arm or a tracker, it's very beneficial to set your alignment and get your CAD file lined up how you're going to do your alignment or how you're going to set it on the CMM. To do that, it's always the first thing I do when I bring in my CAD file. There we go. Is I'm going to come in, operation, graphic display, transform. So I'm always going to transform my CAD model right away so that I get my z-axis going where I want, x, y, and my origin. I always start by trying to rotate it. So let's say I want to flip this part over. I choose my rotation axis. Yep, I'm going to rotate on my x-axis here at 180 degrees. And when I hit apply, it will then flip the part over. All right, that's a good start. Now I want to move an axis. If I know how much I want to move it, I want to move by 50 millimeters. Could have been minus 50. I can type that number in, and I can move my origin there. A lot of times, you'll have no idea where that actually is. So it's easier to go in and select a point. I want to move my z-axis to that surface there. And it'll then put that value in for me.
One thing I'd like to say on this, you are moving the CAD model. You are not moving the trihedron. That took me a bit to wrap my head around. I always thought I was moving the trihedron where I wanted it. You are actually rotating and transforming the CAD model, not the trihedron.
Another note on that too, if you were to go in and start programming features before you try to move your CAD model, you will get a message that says the features will not be transformed. You can do that, but it will break the link to everything. So your features will no longer be where they should be. I wanted to rotate, not translate. Good thing, if you're not sure, I translated, not rotated. You can use the right-hand rule to figure out which way your rotation is going to go. I always just guess. If it's 90, I'll put 90 degrees in and hope for the best. And if it's wrong, I'll just do it again. So now I've got my CAD model all set up the way I want it. You can see my circle is no longer where it's supposed to be because I moved the CAD model. Another common thing I've run into, especially with laser scanning, but also when using auto features, is the CAD vectors. Quite often when a CAD model is made, they may have a surface that's the wrong way, like this one. The surface vector on this CAD model is intentionally set up incorrect so that we can fix it. So I can go and I can select a surface and say, yes, fix the vectors. And it will go in and it'll flip the surface vector for me. Typically what I do on a CAD model, if I find one that's wrong, I'll go in and I'll just select the entire thing and say, go ahead and fix it. It does a very good job. There's very good logic built into it that it'll go and fix all those vectors. If you don't do that and you're using auto features, it may try to put the points on the inside of the part, and that won't be something you can measure. Also, if you're doing any laser scanning or color mapping, you will get no data on those if you don't fix them. Another option there is under Edit, Preferences, Import Options. We can set that to automatically fix the surface vectors every time. You can also change the colors and of your default import. If I prefer the gray, if you want a different color, you can change that there. And now every time I import my CAD file, I will not have to go and fix those surface vectors. But now you'll see they were automatically corrected as they came in. If you did have something on your CAD file that comes in that you want to delete, extra lines, surfaces, something like that, we can go in and delete CAD elements. Be careful doing this. Once they're gone, they're gone. I select that surface. I no longer have that surface on my CAD file. I'll have to re-import that and start over. One other note, in this icon right here for assembly, if I had an assembly, I would have multiple items showing in here. At this point, I don't, but that will allow me to turn off any assembly functions or pieces that may be as a part of my CAD model. Again, if there's any questions, go ahead and throw them in the chat. We'll have some time at the end here to discuss those. Now that we've got a CAD model in there, next most common thing we've got issues with is alignments. And John's going to talk about that.
Okay. It's everybody's funnest thing. So let's get a new CAD model in first so we have all of our surfaces. Did you bring an Aegis?
Yeah.
Okay. So one thing that we talk about is progressive alignments. If you have to level your part first before you start doing anything else, the reason for that is your approach vectors won't be correct. Now, how far off are they? It's going to be how far off it's square to the machine. Well, how well did you load the part on the machine? If you're setting it straight down on the granite, you know you have good parallel between the bottom surface and the top surface of your part. That's great. We don't always know that. Real quick alignment. So from here, excuse me, a couple of things that we can do. One of the things is this quick align button. And when you do that, PC-DMIS automatically does that progressive alignment. So if we expand it, Because they're planes, did it not do it, Brian?
I think it will in the DCC.
Oh, that's right. Okay. So we come in with our alignment and it's going to start doing everything. So it leveled the part in DCC, it set the part, and then it went back and it did the same things that it had done before with the manual features. The reason it does that, we come in and we just take points on top, just what I did, and we take a plane over here and a plane on this side. We don't always know that our vector's correct. That's what I said earlier. So the first step for us and then we insert alignment new. We can also go up here to the drop down and grab those. I didn't end it, so I didn't have a feature. At a minimum here, we need to level that. After we level it, then we know that our points on the sides of the part, or if we're going to use this diameter in here as a circle as our datum, we know that our vectors are going to be right to that top surface. If you're doing portable, progressive alignments are a must. If you don't do it using portable, it will flip the CAD model, it will flip the parts, vectors will be wrong, measurements are bad, and you spend a lot of time trying to figure out why. So as we build these, that's what we should be doing. PC-DMIS does it default if you're using that quick align button. So one thing that, whoops. That setback. One thing that I get questions on is this rotating. What is the to and what is the about? So the to, I like to tell people that's the direction. That's your surface vector for the feature that you are, it's your, I'm sorry, not surface vector. It is the vector for the feature that you are going to rotate. In this case, for the plane, it's going to be X plus. If we had a line in there, it would be either X plus or X minus. If our line was on this edge over here, we would go Y plus, Y minus. So in this case, we're going to go, because that surface vector is pointed to the Y minus. So we're going to check the Y minus. The about, most of the time, the about is going to be whatever you leveled to. Leveling is, you know, that breaks the, doesn't break the alignment, but that sets everything back. If you level, if you re-level your part, you need to re-rotate it. So rotating, we are just rotating about this top surface is all we're doing. We're going to rotate at Y minus. Our trihedron's floating around right now. Now it's only being translated. We can go back and set that as our Y origin. And now we only have to worry about our X axis. That's the only thing left that's moving. And we can kill that with a nice little plane. Go back. From here, one of the things is this auto align button. This auto align button is an easy button, but you have to have your features selected in the correct order. It does a nice job of working it out as long as you've got them selected in the correct order. In this case, it knows I selected plane 1 first. That's our top surface. So it's going to use plane 1 to level. It's going to use plane 2 to rotate because I selected it first. And we can see right there, rotated Y minus about Z to plane 2. If we go in and take another one, but I'm going to select plane 3 second, and I hit that auto align, now it's rotated that plane 3. it's doing it right. It's just, if you're using this auto align button, make sure you are selecting those in the correct order. That's one of the biggest things that I had trouble with when I started, and one of the things that we see, people might grab those in the wrong order. In this case, this sort is backwards for me from the way I see it. So I would have done that. I would have selected the wrong plane first. So just one other thing to keep in mind while you're going through all this. You know, again, what are the errors of not doing a progressive alignment? How square do you have the part to the machine? If you level, then you can do a 2D feature, which would be a line. After you rotate, that's when you can start doing a point. Points are a 1D feature. If we just came in and took a point on that edge without an alignment, again, our approach vector and our probe comp would be off, however square we are to the machine, or however not square we are to the machine. And that covers it. We are flying through this stuff. So that covers everything under alignments. Brian's going to do a little bit with work planes and 2D features. And got a question. You can use it with anything. The question is, can we use auto alignment with only planes, or can we use it with points, lines, and planes? You can use it with anything. If we go in and we use a cylinder there, and we have a point over here, do something like that, and then we do an alignment, and we grab the cylinder. Let's do one more thing. Let's do a line here. Whoops. Yeah, I got the point. So we go into the alignment, and we've decided we want to use that cylinder, and then we're going to do the line, and then plane one, we had auto align. It's going to level the cylinder, sets the origin, and then it rotated that line. And then lastly, it used plane one to set our Z. So the question, yes, you do not have to use planes. It can be any feature. If we tried to select a point as our second feature, PC-DMIS will give us an error that says you can't rotate a point. So you're limited that way, but you can use any feature that is valid for the order of precedence.
Just one other note with the alignment utilities that are available. This quick align, a lot of people like to use it. It is another easy button. It's important to understand what it's going to do. If I have, delete all that. If I have 3 planes that I've measured, and I measure them in the order of my datum precedence, so datum, we'll say ABC is my structure. So I measure them in that order. I measure them in the order I want, order of my datum precedence ABC. I go up and I use the quick align button like we saw before. It will go in, it'll do that progressive alignment, and it'll create the alignment that I'm looking for. Now, it can be somewhat troublesome if I go up and I just maybe measure a circle and I hit the quick align button. Well, if I'm not sure what it did in the background, it may do something that I didn't expect. So just always caution everybody, if you're going to use this, make sure you understand what it's going to do. And always good to go back in and take a look in the alignment utility to see what did that button do. Maybe I expected it to level, rotate, and set origins. Well, when I look here, I can see all it did was set X and Y origin. So make sure you're going back and not just accepting that it did everything you hoped it would do. Go back and double check that. One of the other common things we run into is either working planes or work planes or projection planes. So the difference between those is your work planes are going to be based on your alignment. So I'm going to stick with your kind of 6 cardinal directions here, X, Y, and Z, plus and minus. And that is if I wanted to measure a distance between these 2 circles, and I want to measure that in the Z-axis. Gotten this question quite a few times of somebody goes in, says, I need to know the distance from circle 1 to 2 in the Z-axis. They open their distance dimension, select the 2 circles, and how come I can't select Z? Well, that's because I'm currently in my Z plus working plane. So that is, turn the probe off here, looking in this direction. Right? So there we go. When I'm looking at these 2 circles, I can't see any Z height. There's essentially no depth perception is the way I like to look at it. If I rotate the CAD model this way, and I'm looking at it now in my Y plus direction, I can see that Z height. That's where I would go in and change my work plane to Y plus or Y minus, looking at it from the same angle. Now when I do that distance, I have my option for my Z-axis. So that's going to hold true whether I'm doing a distance or if I was measuring something like an angle, same idea. Where I measure these 2 lines. And again, if I'm in my Y plus work plane, I can now see my angle there. You notice in PC-DMIS, it will give you based on the direction of the lines. It'll give me my nominal angle. Another common thing is it says, hey, 330. I actually want 30 degrees. I type that in there. It will then make that change for me and give me the other angle. If you have more questions on the work planes, we'll come back to that. Or I'm sorry, projection planes. Another common thing I've run into is when we try to measure this, an angled surface, or I'm sorry, a circle on an angled surface, typically without CAD. If I'm using CAD, it will figure it out for me, but maybe I'm just probing it on the part. I can create what's called a projection plane as well. And to kind of explain this, I think the easiest way to explain it is to show you here of how it can be used incorrectly and then the correct way to use it. With the projection plane, if I go in and I try to measure this circle with 4 points, you notice PC-DMIS will ask you, do you want to change the projection plane if you're in the wrong one? So there it said, hey, it looks like you're trying to measure a circle, but you're in Y plus, looking at it from this angle. You want to change it? Said yes, and it changed it to Z plus. Now, if we look at that circle that I just measured, and those 4 points, that doesn't look correct. Because what it's doing is looking at it in the Z plus plane. We can see that that circle is not what I'm trying to measure. If we look at the diameter, should have been 18 millimeters, measuring at 16.3. And we're also getting pretty significant form error. What it's doing is projecting it to that Z plus plane. What I want to do is actually put my points, delete that circle. I want to project those to this plane here. So instead of using Z plus, I can override that and say, I want to project to plane 4. That is now my projection plane. From here, when I take my points, you'll see it projects those perpendicular to that plane. One more. So whether my points are being measured correctly all in one level or my level's moving up and down as I took my points. When I measure that circle now, you'll see I get the correct diameter and I get a zero form or zero error for my form there. Again, that's because I'm from a CAD model, but on your part, you will see something that should represent a reasonable error. So this is important no matter what you're measuring with of using that projection plane. It's extremely important when measuring with a portable device, like an arm. That's because no matter how good we're trying to take our measurements, those points are always going to move up and down. Whether it's in the Z-axis, X or Y, no matter where I take my points here. I can try to stay at the same level, but my points are always going to move up and down to some degree. And there I've measured a cylinder. So that happens quite a bit when you're measuring, especially with portable devices, is measure with the cylinder. Since that happened, another common question is go up to edit, override guess, and change your feature type. That wasn't on my list, but it happened, so I thought I'd show you. They're flying through all this.
Yeah.
It's kind of what I had as a quick description of the work planes and projection planes. Do you have any other questions? Anything to add there?
No, that's all we had set up for kind of our quick hit stuff. One thing that I did notice, let me go back here. I just want to, what I noticed when Brian was doing some of this stuff, not all of the buttons were showing up. Some of the drop downs weren't coming in. So this is what you get when you click on the work plane or the projection plane. You'll get a list of your features in there that are valid for what you're doing. Another thing that he was doing some stuff in the edit window as far as CAD vectors and things. This is where all that stuff lives. It just wasn't showing up. We were only sharing one, just the window, not the entire screen. So that's why that stuff wasn't coming in. So that's it. That's what we had as our quick hitters for the stuff that we get a lot of questions about. If we continue on with these, which we plan to, we're going to start getting more in depth with more stuff. Any suggestions that you guys have or anything you want to see, any questions you're having, any common questions that come up at your shop, let us know. We'll add them in, and you can always reach out to us and we'll get back to you as quick as we can. Brian or I, we've got 3 other guys in the lab that handle a lot of the PC-DMIS stuff. So we can get back to you pretty quick. We might not have all the answers, but collectively we probably do. So if you ask me and I don't know, I'm going to go to Brian. So
I don't know. We've got, as John said, a bunch of other guys we can go to as well.
Good.
Yeah. If you got any questions, go ahead and throw them on there. We can
we'll get to them
for a little bit here.
If not, feel free to drop off. We'll stay on for a little bit in case anybody wants to ask a question. But hey, thanks everybody for attending. Appreciate it. You will be getting an email with a link to the full thing so you can watch it again if anything comes up later. Absolutely. We can do, we could probably go a little scanning right now. We've got time. We're on the books for, he wants to know, if we can include scanning, some basic and advanced. Absolutely.
Sure.
We can go through that right now. We're here till, we scheduled another 20 minutes on this. So any questions, let us know. We'll just do them right now.
So, we want to talk about scanning features. We can start there, I suppose. There's different ways to do it. Probably the simplest is going to be through the auto features. When you start programming in here, you're going to come in, whatever your default is set for your system, you'll see. So in this case, this isn't going to work. We need to go to DCC. Oh, we are. All right, try that again. All right, so within my auto feature window here, you'll see my default measurement strategy is the default PC-DMIS measurement strategy. That's on this second tab. Excuse me. One of the simplest ways to go in and start scanning features is to use the adaptive auto features. So I can go in and do an adaptive circle scan, and you'll see that's going to change my path lines there. From here, there's quite a few options. If we just leave them all alone and we go ahead and scan, it is going to do the scanning at whatever your machine default is set to. Typically, I see them around either 10 or 20 millimeters a second, potentially slower. With the adaptive circle scan, we have some options here to set for tolerances for size, location, and form, and also what kind of surface type we have, whether it's a machine, ground, or cast. Based on these settings that I choose, that's going to affect the speed that it scans at. Obviously, if you're working with a cast surface, best to select that so it scans a little slower. There's some advanced options. We can override those speeds. Typically, you're going to leave those alone. Filtering, some different things there, the way it's going to scan. Sorry, go back to the filters. Be careful of this. If you filter too much, you will filter out some valid data. Kind of leave that up to you on how you want to use those. And then some other options without getting too deep into it. But again, the simplest way to do that, scan there. If we want to create that. Works the same way with something like a line. I pick my start and end point. There you can see my 3 touch points from my default strategy. And change that to an adaptive linear scan. So again, now it's going to scan that edge. Cylinders kind of work the same way. There's more options there. Now we've got adaptive line scan, where it'll scan lines up and down the cylinder, or the spiral scan, another option. With the spiral scan, we do have to give it a pitch. So as I put a number in for pitch, you'll see that's how it's going to spiral. If I change that to 2, I'm going to get less of a dense path as it spirals around.
One thing with spiral scanning, a lot of the stuff in PC-DMIS, if you're using GeoTol, by default, we'll use opposing points. If you are spiral scanning, you don't have any 2 points that are exactly opposing. It will interpolate and do the best job. Just something to keep in mind. Don't be afraid to use them. Just understand how PC-DMIS is going to evaluate it. By default, some stuff is opposing points. You can change it to circular elements, which then you always have a circular element with a spiral scan.
Typically, for me, when I'm going to use GeoTol, if I'm doing cylinders, I'm going to use the concentric circles so that I always have opposing points. But yes, as John said, the spiral works well. It's a quick scan. It'll definitely save you some time if that's the one you want to use. Beyond using the auto features, there are many other scans you can do. Not going to go deep into them. If you've got a specific question about one, we can definitely do that.
Do just the shift click scan, drop it in a linear open.
If you're using the shift and click, if you're using the measurement strategy wizard, didn't think of what it was called there for a second. We have the option in here, whatever my default is set, I have the option to go in and change my scan path on something like a plane. And that will do a perimeter scan is what I'm doing there. So you're going to see it's going to create that scan path around whatever my CAD offset is from the edges. You can also do a freeform scan where I'm holding down Shift and Control, click and drag, and it will create a scan path there. Real simple way to create a linear open scan. Just give it my start and end point. I missed one of my surfaces there. Try that again. You can see as I cross those surfaces, it's selecting them. And essentially I'm giving it a start direction and an end, and it's going to create that scan. Real simple way to create those linear scans. It's a linear open. Again, if I look at a dialog, it'll create a start, a direction, and an end. If you wanted to define that, you can come in here and select those points, but that is the easiest way to set that up. Again, there's probably 8 or 9 different scan types we can do. Perimeter scans, freeform scans. That's another one that people like to use a lot. Another very easy one is a scan freeform. And from here, you can come in on your graphics. You can choose particular CAD surfaces that you want to use. And then probably the easiest way to use this is go into your path definition and start selecting points. See, I'm drawing all these points on here. And I can create that path. And whatever my increment is, when I calculate that path, it'll spline all those points. You see it rounded the corners. So I just want to try to put enough points in to get around everything I need to get around. And I've now created that scan path.
So that's quick on scanning. We will do a lot more with scanning. We had some time, so we touched some of the high points on it. What Brian was doing, dropping in these 2 scans here with that Control, Shift, and click, I use that a lot. It's really easy to get a lot of data on these surfaces because you can just keep putting them on there. If you want to go over the whole, not set up for that. There's some stuff inside the scan that will allow you to set your jump holes. Oh, I think I bombed it out.
Oh, the widget's open.
Yep.
There you go.
Under the path definition, jump hole, and then your edge offset. So how far away from the hole am I going to jump? So that is saying how far from the CAD edge will I be before I come over the hole? So we were to start here and go this way. Close that. Let's do a new insert and linear open. This is how you go in the short way, or actually the long way. Go ahead and select our graphics. We're going to grab that top surface. I'm going to go back, turn this to a defined scan, set our path definition, a start, a direction, and an end. We in inches or millimeters?
I believe 1 millimeters.
Okay. So we set that at 2. Give it a 2 millimeter offset, and we tell it to jump the hole. As you can see, it 2 millimeters away from that CAD edge, it's going to pick up and make a new scan. So if we go ahead and say create, when we open that up, I'm sorry, if we were to expand that, it would have 3 distinct scans in there for us. So all under scan 7, but there'd be scan 7 line 1. You can see it right there a little bit. We hide that. So you got a basic scan with 3 hits, 2 hits, and 3 hits. So it puts 3 scans in that one command. So we will get more in depth with scanning at a later date, probably on the next one. One other question we had was about clearance planes and clearance cube. Question is, I always resort to using clearance planes. When would it be an advantage to use a clearance cube? With clearance planes, you have to manage going around corners with clearance planes. If you drop in a clearance cube, it's going to manage all that for you. We just activate our clearance cube motion, and then we show the clearance cube. It puts a box around the CAD model. If you had a fixture, CAD with the CAD on it, it would also include the fixture. So it's going to miss everything. What it's saying, it works the same as a clearance plane. It's going to move outside that box before it makes another move. So it's going to make a feature, come outside the box, move, go to the next feature. The advantage to it is you don't have to manage going around corners with it. And they've got a new, as soon as I put in a clearance cube, this extra window opened. I'm going to go ahead and shut that off. So if we start putting in, we just drop in a plane. And now we can manage our clearance cube from here. We can turn it on or off, or we can tell it right now it's defaulted to use the tip vector. So if we were going to measure that plane that I just put in there with a probe at A0, B0, it's going to show up. It's going to come right above the part, but we can say, hey, we can approach it using the tip vector, but maybe you want to leave going Y minus. So for whatever reason, you're going to come away from it and then do an index or something. It will drive itself away from the part in Y minus. It handles probe changes as well. So if you're going to, and when I say a probe change, I mean a wrist change, an angle change, it will move away and go up to a safe distance above the part and do that index. Some of the disadvantages that I've had, the biggest disadvantage I had using clearance cube is if I'm using a star probe, every time you select a new tip, it wants to come above the part, above the CAD model. It's getting better. That's something that I haven't done since they've added this new functionality with this clearance cube window. So cases, if you're using a star probe, be cautious with using clearance cube. I don't know how it works yet. You know, if you're inside a part trying to measure snapper and groove or measuring underneath a part and you switch the probe angle or switch the probe tip, just be cautious that it has the potential on older versions of software of driving right through the part, trying to get to the top so it can change tips. So that's the difference between clearance cube and clearance plane. They work the same. You can turn them on and off per feature. What's nice with the clearance cube, you can approach it using the clearance cube. If we were going to do, if we were going to measure this surface separately from this surface, we could turn it on, approach vector on for this one, and then say off to get away from it. And then if we come over here, whoops, and we want to measure that guy, here we would say, I'm sorry, I clicked the wrong surface. So if we were going to measure those two separately for this one, there we go. We've got it turned on to approach, off at the end, and then plane 8, which is this next surface, we could turn it off to approach. That way it doesn't come out of that clearance cube and go back into it for that second surface. Kind of eliminates that sewing machine motion that it has. Same as with a clearance plane, you can turn those on and off in the feature. So.
If you avoided using the clearance cube in the past, as of 2023, I believe is when they put this window in. Makes it much more friendly to use. I know I found myself using it a lot more, just a lot easier to make the adjustments with the motion. So you haven't used it in the past, maybe give it a try. It's that window makes it a lot more friendly to use.
All right. All right, everybody, we do appreciate you joining. Again, we'll send this out. You'll get a copy of the video, the recording, and we look forward to seeing you guys in the future. We're going to plan on doing more of these. So if you have any suggestions, send them to us, send them to Hannah, me, Brian. All of our contact information will come with the link. So again, thanks for taking the time, and we appreciate it.
Thank you.